Hello, I wanted to talk about ergonomics, and ergonomics is an important tool for the designer. It lets you apply a technical element to your creative work, and ergonomics is guided by just a few principles and some data. So the concepts aren't hard, the data is out there, and it's just another layer for the designer to use in developing really good work. So ergonomic principles are really founded, I think, on three things, namely recognizing that people are different, recognizing that the body's neutral position is the most efficient, and recognizing that repetitive motions cause problems. So if we look at those three things, and I guess I could do them in that order, people are different in dimension. We all know that. And again, none of this is rocket science, but we know that people are different in dimension, and that field of study is called anthropometry, and you can obtain anthropometric data from many sources, and it will tell you how long is an Uzbek woman's arm, what is the reach of a Kazakh 10-year-old, what is the wrist diameter of a German male. All that data are available, and it's called anthropometric data. You look at it statistically, which I'll talk about a little later because I don't want to talk about statistics too much here, but you can find the data. So as professional designers, you're trying to design for the other, so you get that information and work with it. Here is a anthropometric person, and there's simple proportional relationships between your height and all these key joints, and you can quickly make a person too, so you can do a mock-up, and you can, for example, put on a little top here and get sight lines and so on. So you can build anthropometric people very quickly, and that gives you a sort of a physical model to work with. Of course, you can work with just raw data too. And again, I'll talk briefly about statistics later. The second principle was knowing that the neutral position is a position that is best for people to be in. What you want to do is design everything for someone who's floating in a swimming pool, floating underwater in a swimming pool with scuba gear, where the body's in the neutral position. And this means basically that the joints are at the middle of the range of motion. And that's all there is to it. So you don't have too much extension or flexion or pronation or any of these other issues with the body, but you keep it in the neutral position. And that kinesiological information is out there, and you just find the middle of the range of motion, and you're done. Of course, in practice, when you're working with something real, you can't always keep the body in the neutral position, but that's the ideal. If you know that, you're in good shape. And there's some rules of thumb that are connected with that. For example, we talk about affordances and constraints. And affordances are design features that allow you to use something. Constraints are design features that don't allow you to use something. So the handle and scissors are affordances for the hands, or the fingers. And they're constraints for you sticking your head in there. So you make something to prevent injury. You see that a lot in children's toys. So you can't. You make it too small to stick some things in, and you make it big enough to stick other things in. And these are called affordances and constraints. So there's some rules of thumb you can use. For example, the affordance for a thumb is 35 millimeters. And that's just the typical number. For a power grip length, about 100 millimeters. If you look at tools, for fine equipment, I think it's about 15 millimeters diameter is a recommended size. So there's a lot of that information out there, and you just have to find it. It's available in books and online and so on. And GrabCAD even has some models you can pull in too, which is helpful. Then we look at repetitive motion problems. Carpal tunnel syndrome is probably the most well known, and you want to make designs in such a way that they reduce the need to do repetitive motion. So a typist can type 100,000 keystrokes per day. It's a lot of motion, and our bodies are meant to be used, so it's not evil certainly, but if you can reduce that by design, that's a good thing. So I have, for example, here we just have a model of the joint, and we make up these models and kind of play with different things, and this is the sort of thing you can build kind of quickly and really understand the anatomy of joints, which are really a big issue in design. So this was made of Super Sculpey and 1x2, some of my favorite things. And you can make up different joints and get a real feel for how the body behaves. I want to look at another couple other kind of loosely associated areas with ergonomics, namely comfort, and then I'll try to talk about statistics briefly at the end. So here's a paint booth I have, and if you look right here, you can see there's, maybe you can see there's duct tape and there's some foam here. And that's because when this was installed, the switch was put on the top and I cut myself one of the early times I used it. So I put this there to protect my hand, and by putting it there, it kind of solidified my knowledge that that's a dangerous curve. So I filed it and all these sort of things. But the point is that people understand this stuff. So if you look at objects that are used, and you can see how they've been modified for the user. You can see where things have been taped, where things have been scratched, where things have been worn. You can learn a lot about actual usage by looking at objects. And I'd like to at some point talk about ethnographic design, because that sort of that topic kind of melds into ethnographic design. So anyway, that's just a physical feature. As you know, as an ethnographer, you're very observant of these things, and you ask, why is that there? But anyway, let me turn this on for a second. You hear that annoying sound? Sound is part of the whole comfort issue, and we'll talk just briefly about some of the comfort issues. But there's certain sounds we like, and there's certain sounds we don't like. There's certain sounds that young people can hear that older people can't. So, for example, above 10,000 hertz, as you get older, you just can't hear those frequencies anymore. It's amazingly consistent across populations. So you have the perception of sound can be different based on your age, just as the perception of color can be based on your unique physiology. So we just want to recognize that, again, in professional design. Then you and with sound, you have if something's too quiet, tomb-like, that's offensive. So often there's minimum standards for sound. So you don't hear papers shuffle and these sort of things. And then of course there's maximum limits for sound dictated by OSHA or other regulatory agencies, so as to avoid harm to people. And animals are a whole different issue. They have higher sensitivities to certain frequencies, of course, and I won't delve into that. But comfort is also unique too, because the American Society of Heating, Refrigeration, and Air Conditioning Engineers describe comfort as a condition where 80% of the people are not experiencing thermal discomfort. It's a convoluted definition, but it's basically saying you'll never make everyone happy. So environmental comfort is related to noise. High noise is not comfortable, it's offensive. If it's too quiet, that's not attractive. But then there's other issues too. For example, carbon dioxide. If you have a high carbon dioxide level, you'll feel more drowsy, less attentive, and you can't detect the level of CO2. Humans can't. So environments have to be designed with good ventilation systems to bring in expensive outside air, because you have to heat or cool it. Then too, you have temperature, of course, and humidity. So you're familiar with the interplay with those. You also have solar radiation, or any kind of radiation, like radiant floor heating systems and so on. So you can have a cold room, but it's got a radiating floor or ceiling even, and you'll feel more comfortable. It's also a function of draftiness. So if a register is blowing on you, you'll feel colder than you would otherwise, wind chill factor. And those components all come into play to making people comfortable. So that's just a little side note on comfort, sort of related to ergonomics, because when we talk about ergonomics, you're talking about scientific principles that relate human bodies, human physiology, I guess I could say, to a design. And comfort is part of that as well. When you touch something, is it hot or cold? And what sense do you desire for the person to have? When they touch metal, they expect it to be cold, and these are part of the issues that come up in sort of the ergonomics. It's part of the whole design approach. Briefly, just want to talk about statistics. I had mentioned initially, when we talked about one of the guiding principles being that people have different dimensions, and those dimensions are described by anthropometric data. That anthropometric data is in turn described typically by two values, a mean and a standard deviation. And when you have a bell-shaped curve, that data can be described with a mean or an average and a standard deviation. So if data is tightly clustered about the mean, you have a small standard deviation. If it's spread wide from the mean, then you have a large standard deviation. So the mean and the standard deviation tell you a lot. And so with anthropometric data, you're often given information on how big all but the top 5% of the people are, or how small all but the smallest 5% of the people are. In other words, you work between, you often get data on the from 5% to 95% of all people. So you get to pick those numbers, but that data is out there a lot. So you can say, I want this pencil sharpener to work for 100% of the people. Well, then you've got a lot of data to work with. If you throw some of the people under the bus, then you don't have to make such a wide range of dimensions for a design. That's commonly done. I could expand on that a little bit. For example, I mentioned one of the guiding principles being that people are different and you should accommodate that, but when you're designing a toaster, you don't want to make toasters for all kinds of different people. It has to be sort of universal in that way. And the same is true with power tools and all these sort of things. So you try to get most of the people, and if you get 100% of the people, your dimensions, the dimensional range of someone's reach or their wrist diameter or whatever is going to be all over the place. It's going to be very wide ranging. If you focus that into this sort of 90 percentile, the 5 to 95% group, then you have a much smaller window to work with. And of course, men and women are different in terms of dimensions. So what I do with this is I take all this data and some of these rules of thumb and I throw it in Excel and have Excel carry the data, do the math. It's not hard at all. For example, when you deal with anthropometric data, the level of math required is trigonometry at the most. It's just a geometry problem. And statistics, you don't need a lot of knowledge of statistics. You just have to recognize what this mean and the standard deviation applies to. So again, in summary, the guiding principles for ergonomics are that people are different sizes, they want to be in the neutral position, and that repetitive motions cause problems. And a last note, I should mention that dexterity decreases, of course, with reach and strength. So the further away something is, the less strength and dexterity I have. So you'll see that in the National Electric Code where they ask you to keep the control panels close to the chest, and you recognize that if you reach into something and have to twist your arm, you don't have very good dexterity. So common sense, and there's some really interesting graphs that show that sort of thing. So that's pretty straightforward. Thank you.